So here we have x plus cosine of x divided by tangent of x. So let's find the derivative with respect to x. So we'll get tangent squared x in the denominator. So we have tangent of x multiplied to the derivative of the numerator. So let's write it by applying the derivative to each of the terms in the numerator. So we have derivative of x with respect to x added to the derivative of the cosine function minus x plus cosine of x multiplied to the derivative of the tangent function. So we get tangent of x times derivative of x will be 1, and we have derivative of the cosine x, which will be negative sine x. So we have negative sine x minus x plus cosine of x multiplied to derivative of the tangent function is secant squared x whole divided by tangent squared x. So that's it. So this is the derivative. Let's move on to the next question. So here we have the function x over 1 plus tangent of x. So we need to find its derivative with respect to x. So we begin with the function in the denominator, which is 1 plus tan x. So we write the function in the denominator and then square it. Then we write the same function in the numerator, 1 plus tan x, and then multiply it to the derivative of the numerator, which is x, minus x times the derivative of the function in the denominator, which is 1 plus tangent of x. So that will give us 1 plus tangent of x multiplied to derivative of x, which is 1, minus x times derivative of 1 with respect to x plus derivative of the tangent function, which is tangent of x, divided by 1 plus tangent of x whole squared. So we have 1 plus tangent of x minus x times derivative of 1 will be 0, and derivative of the tangent function is secant squared x, divided by 1 plus tan x whole squared. So this is the required derivative. Let's move on to the next question. So here we have x raised to the power of 5 minus cosine of x divided by sine x. So let's find the derivative with respect to x. So we'll have sine x whole squared in the denominator. Then in the numerator we have sine of x multiplied to the derivative of the numerator, which will be derivative of x raised to the power of 5 minus the derivative of cosine of x, minus x raised to the power of 5 minus cosine of x multiplied to the derivative of sine of x. So that gives us sine x times derivative of x raised to the power of 5 will be 5x raised to the power of 4. Derivative of the cosine function is negative sine x, so we'll have positive sine x, minus x raised to the power of 5 minus cosine of x multiplied to derivative of the sine function is cosine of x, divided by sine squared x. So we will have 5x raised to the power of 4. So we're multiplying sine x to the two terms. So we have 5x raised to the power of 4 times sine x plus sine squared x. Then we have negative cosine of x multiplied to x raised to the power of 5. So we have negative x raised to the power of 5 times cosine of x. Then we have negative cosine of x multiplied to negative cosine of x. So that will be positive cosine squared x divided by sine squared x. Now sine squared x plus cosine squared x in the numerator will be equals to 1. So we have 5x raised to the power of 4 times sine x minus x raised to the power of 5 cosine of x plus 1 divided by sine squared x. So this is the derivative. Let's move on to the next question. So we have secant of x minus 1 divided by secant of x plus 1. So let's find the derivative using the quotient rule. So we'll have secant x plus 1 whole squared in the denominator, and we have secant of x plus 1 multiplied to the derivative of secant of x minus the derivative of 1. So this is the derivative of the numerator minus the numerator times the derivative of the denominator, which will be derivative of secant of x plus the derivative of 1, which will be equals to secant of x plus 1 multiplied to derivative of the secant function is secant of x times tangent of x the derivative of 1 is 0 minus secant of x minus 1 multiplied to derivative of secant of x, which is secant of x times tangent of x plus derivative of 1 is 0 divided by secant of x plus 1 whole square. Now we can take secant of 1 as the secant of x, secant of x times tangent of x as the common term. So we'll get secant of x times tangent of x. This is the common factor, so we'll be left with secant of x plus 1 minus secant of x minus 1, so that will become negative secant of x positive 1 divided by secant of x plus 1 whole squared. The secant of x gets cancelled and 1 plus 1 will be 2, so we'll be left with 2 times secant of x times tangent of x divided by secant of x plus 1 whole square. So this is the derivative of the given function with respect to x. Let's do another problem. So here we have 4x plus 5 sine of x divided by 3x plus 7 cosine of x. So let's find the derivative with respect to x. So we have 3x plus 7 cosine of x whole squared. We have 3x plus 7 cosine of x in the numerator multiplied to the derivative of the numerator, which will be 4 times the derivative of x plus 5 times the derivative of sine x minus 4x plus 5 sine x multiplied to the derivative of the denominator. So that will be 3 times the derivative of, so here I've missed an x, derivative of x plus 7 times the derivative of cosine of x. So that gives us 3x plus 7 cosine of x multiplied to 4 times the derivative of x is 4, and 5 times the derivative of sine x will be 5 cosine of x minus 4x plus 5 sine x multiplied to 3 times the derivative of x, which is 1, so we have 3 plus 7 times the derivative of cosine x, so cosine of x will give us negative sine x, so we'll have negative 7 cosine of negative 7 sine of x whole divided by 3x plus 7 cosine of x whole squared. Now we simplify the numerator, so we have 3x multiplied to 4, so that will be 12x plus 3x times 5 cosine of x will be 15x cosine of x plus 7 cosine of x times 4 will be 28 cosine of x plus 7 times 5 will be 35. Cosine squared multiplied to cosine squared will give us cosine squared x minus 4x multiplied to 3 will be 12x minus 4x multiplied to 7 sine x will be 28x sine x plus 5 sine x times 3 will be 15 sine x minus 5 sine x times negative sine x will be 35 sine squared x whole divided by 3x plus 7 cosine of x whole squared. So now we get rid of the parentheses. So we have negative 12x, that will make positive 28x sine x. We have negative 15 sine x and positive 35 sine squared x. So 12x and negative 12x will get cancelled. So we have 15x cosine of x. Then we have 28 cosine of x. Then we have 28x cosine of x. Sine of x. And the minus 15 sine of x. Plus, now when we take 35 common, we get cosine squared x plus sine squared x, which is 1. So we'll be left with only 35 here. Whole divided by 3x plus 7 cosine of x whole squared. So this is the derivative of the given function with respect to x. Let's move on to the next question. So we have 10 raised to the power of x divided by sine x. So let's find the derivative using the quotient rule. So we have sine squared x in the denominator, then in the numerator we have sine x multiplied to the derivative of the numerator minus the numerator times the derivative of the denominator, which will give us sine x times derivative of 10 raised to the power of x will be 10 raised to the power of x times natural log of 10 minus 10 raised to the power of x times derivative of the sine function is the cosine function divided by sine squared x. Now we can take 10 raised to the power of x as the common factor, so we'll have sine x times natural log of 10 minus cosine of x divided by sine squared x. So this is the derivative of the given function with respect to x. Let's move on to the next question. So we have 3 raised to the power of x divided by x plus tangent of x. So let's find the derivative using the quotient rule. So we'll have x plus tangent of x whole squared in the denominator, and in the numerator we start with the denominator function, which is x plus tangent of x multiplied to the derivative of the numerator, which is 3 raised to the power of x, minus the numerator times the derivative of the denominator, which is derivative of x plus derivative of tangent of x, divided by, so we'll get x plus tangent of x times, so derivative of 3 raised to the power of x will be 3 raised to the power of x multiplied by natural log of 3 minus 3 raised to the power of x multiplied to derivative of x will be 1 plus derivative of the tangent function is secant squared x divided by x plus tangent of x whole squared. So we can take 3 raised to the power of x as the common term. So we'll be left with natural log of 3 multiplied to x plus tangent of x minus 1 plus secant squared x whole divided by x plus tangent of x whole squared. So this is the required derivative of the given function. Let's move on to the next question.